All right, let's take a look at this question. We have evaluate the integral of 1 all over e to the power of x plus 1 dx. We are asked to evaluate this integral. Please pay attention. Now, you know that when you say e to the power of x minus e to the power of x, what will it give you? 0. We know it, right? Because we have e to the power of x in our denominator. That's why we want to use that. It's going to give us 0, okay? And you know that 0 is an additive identity. Okay? It's an identity in the sense that when you add this 0 to any number, the value will remain the same. Okay? So this 0 now, we are going to add it to our numerator. Okay? We're going to add this 0 to our numerator. And then you know that 0 is e to the power of x minus e to the power of x, right? Is equal to 0. Then that means we are adding 0 to our numerator. So we are adding e to the power of x minus e to the power of x. So now we are going to have the integral of e to the power of x plus 1 minus e to the power of x all over e to the power of x plus 1 dx. Look at our numerator. When you say e to the power of x minus e to the power of x is 0, right? Good. Now let's go. Let's split this function we have now, or expression, into 2. In this way, we can say that we have the integral of e to the power of x plus 1 all over e to the power of x plus 1 minus e to the power of x all over e to the power of x plus 1 dx. Please look at this very carefully. You'll see that if you combine these two together, you are going to have the same expression as above. And then simplify the expression above, you have our original question. All right, good. That means we can apply integration into both expressions. That means we are going to have the integral of e to the power of x plus 1 all over e to the power of x plus 1 dx minus the integral of e to the power of x all over e to the power of x plus 1 dx. Okay, now in the first expression where we have e to the power of x plus 1 all over e to the power of x plus 1, you know, we have the same thing in our numerator, the same in our denominator. Okay, so that means it's going to give us 1. So 1 times the x is going to give us the x. So here we have the integral of the x minus the integral of e to the power of x all over e to the power of x plus 1 dx. Is that true? Good. Probably here, let's make use of u substitution. That means we're going to say let our denominator, which is e to the power of x plus 1, be called a letter. Now let's use letter u. So here we say let u equal to e to the power of x plus 1. And let's differentiate this u with respect to x. That means we are going to have du dx is equal to e to the power of x. All right? Okay, now let's cross multiply. In doing so, we are going to see that du is equal to e to the power of x dx. All right, du is equal to e to the power of x dx. All right, good. Now let's go. You know, we have the integral of the x minus the integral of e to the power of x all over e to the power of x plus 1 dx. Now you see that this second expression can be rewritten this way. You can rewrite it like this: the integral of 1 all over e to the power of x plus 1 multiplied by e to the power of x dx. You know, it can be written like this. You know, even this e to the power of x dx can be written as a numerator, okay, directly in this place that is 1. It's still the same. Now let's go. In this place here now, we make substitution. Okay, we substitute for e to the power of x plus 1, and also in place of e to the power of x dx, we replace it with du. Okay, now going with the proper substitution, we are going to have the integral of the x minus the integral of 1 all over, in place of e to the power of x plus 1, we replace it with u. And then in place of e to the power of x dx, we'll replace it with du. So here we have the integral of 1 all over u du. Okay, good. Now let's go. Let's integrate properly. Integrating, the first one, we have the integral of dx is going to give us x, and then minus the integral of 1 all over u is going to give us ln u. We have plus c. But you recall that u is e to the power of x plus 1. Let's replace back. That means we're going to have x minus ln e to the power of x plus 1 in bracket plus c. All right? Yes. Here we have solved and we obtain that the integral of 1 all over e to the power of x plus 1 dx is equal to x minus ln open bracket e to the power of x plus 1 in bracket plus c. Now you can check if this our value is correct by differentiating or finding the derivative of this our answer. Please, I want you to pick a sheet of paper and give it a try. You see that if you differentiate this, it's going to give you the initial expression we have. All right? Yes, thank you very much for watching. Please, if you like this video, please give it a thumb up. Subscribe if you have not. Like and share our videos. Stay blessed.